My name is Jay Moody, and I'd like to welcome you to the 12th annual Hiram Barrett Summerhays Lecture on Science and Religion. This lecture series is made possible by a generous gift from Hiram's son, Brigham, whom I was just talking with over there, who has been a great supporter of the Physics and Astronomy department at BYU. These lectures are sponsored by the College of Physical and Mathematical Sciences here. The Summerhays family has a history of supporting astronomy at BYU, having given the money to purchase the star projector for the original planetarium over 50 years ago. In this series, we have the privilege of honoring Hiram Summerhays and his lifelong love of astronomy, science, and the gospel. These lectures take place at or near the time of the autumnal equinox. Every year we do this. The significance of this time to astronomy is apparent. It is when the days and nights are each 12 hours long and signals the beginning of fall. The autumnal equinox is also the time when Joseph Smith first saw the golden plates, was 4 times instructed by the angel Moroni, and eventually received the golden plates to translate. The dual meaning of these dates make them a natural choice for these lectures. Truth is not in conflict with itself. Religious truth is established through revelation, and scientific inquiry has uncovered many facts that have thus far withstood the test of time and surely must have truth within them. It is incumbent upon us to seek insights into all truth and mesh, where possible, her parts at their proper interface. We discover bridges between scientific and religious knowledge best if we pursue them through study, faith, and dialogue. The charter of this series is to explore the bridgework between the truths that are revealed and the truths that, to paraphrase James E. Talmage, are written in the world around us. We at BYU are charged to teach not even the mathematical tables without the Spirit of the Holy Ghost. But we are also taught by the Savior in Doctrine and Covenants chapter 9 that we must first study things out in our minds before their accuracy and truth will be affirmed or denied to us. In this lecture series, we encourage searching things out in our minds while remaining in tune with promptings from on high. I read that every year. I never get tired of it because there's a lot of truth to it. And if there's any place on the face of this earth where we should be pursuing this kind of things, is it not at BYU? We have had some marvelous people lecture in this series. On these lectures are taped and they're streamed off of our college website and are one of the more popular places where people go on the college site. While we've had a lot of good people, I do not believe, in all honesty, Dr. Grandy, we've had anybody with the qualifications that you have. We are absolutely privileged tonight to have Dr. David Grandy, faculty member from BYU in the Philosophy department. Dr. Grandy earned a Bachelor of Science degree from BYU, did a stint in the Army, did graduate work at Harvard, and earned a Master's and PhD from Indiana. He's authored several books, including The Speed of Light, Constancy and Cosmos, a book on the interface of light and philosophy, Everyday Quantum Reality, Magic, Mystery, and Science, and a book on Leo Szilard, one of the great physicists. And I forgot the full name of that, but a very interesting book, I'm certain. And he wrote a brilliant review of Richard Dawkins' book, The God Delusion, which I think is one of the most temperate and insightful discussions of that I have ever read. He and his wife, Janet, are the parents of six children. And now, in my own disorganization, I think we're supposed to have a prayer before I started with that. So, we'll have a prayer by Joshua Sykes, senior from Dallas, and then I'll turn the time over to you. Dr. Grandy will go 40 minutes, or roughly 45 minutes for the lecture, and then we'll have the remainder of the time till 8 o'clock open for questions. And then we'll have a closing prayer, and you're free to just to talk with Dr. Grandy as long as he can stand it. Okay. Thank you.
Our beloved Heavenly Father, we're so grateful that we are here gathered together as brothers and sisters, and we thank Thee that we know that we are Thy children and that Thou hast created us. We also thank Thee for the learning and knowledge of the world and how we are growing, and we pray that Thou wilt bless us with Thy Spirit this time to help us to understand Thy ways and to help us to progress and grow from this lecture. And we say this in the name of Jesus Christ. Amen.
Well, I'd like to thank Professor Moody for that gracious introduction, and I'd like to thank him for extending this opportunity to me. I'd also like to thank the Summerhays family for sponsoring this lecture series. The title of my talk tonight is Rethinking the Thoughts of God, How Religious Belief Shapes Science. Brigham Young remarked that of all the sciences, astronomy gives the greatest scope to the mind. Some may disagree, but no one can deny the sheer vastness of the cosmos, nor its ability to stretch the soul and spark a sense of reverential wonder. Immanuel Kant, whose philosophical deliberations were often keyed to Newtonian science, famously stated, quote, "Two things fill the mind with ever-increasing admiration and awe. The oftener and the more steadily we reflect on them, the starry heavens above and the moral law within," end of quote. Kant wished to show the outward and inner law were a single package. Each realm of law, whether that which governs the motions of the heavenly bodies or that which regulates correct moral behavior and human happiness, is grounded in reason. Although Kant broke with traditional thought by imputing greater autonomy to human beings than had his pre-modern predecessors, he nevertheless retained their assumptive belief in the world's intelligibility. One could, by the exercise of reason, grasp the design of nature, a design that drew inquiring minds into the practice of science and philosophy. Put differently, mind and nature were cognate principles. Each was rationally structured and therefore fitted to the other. When consequently the key of the human mind, so to speak, turned the lock of nature, understanding occurred. This is the exhilarating experience of science, whether practiced by an advanced researcher or as a young child. When I was 9 years old, I read that an empty glass, turned upside down and submerged in a container of water, would not get wet on the inside. The air in the glass, if not allowed to escape, would keep the water from rushing in. The idea was incredible to me, for compared to water, air seemed like nothing at all. But when I tested it by wadding up a piece of paper and putting it in the glass, I found that it was true. The paper came out perfectly dry. In short order, I performed the experiment at school for my 4th grade classmates. I still remember that after explaining that the water would not get wet, I heard one boy whisper confidently to his friend that it would get wet. Imagine his surprise and my satisfaction when the paper came out dry. This is the adventure of science, and tonight I want to propose the contrary to common opinion. Religion, that is, belief in God, belief in a higher power, has long been part of the backdrop and motivation for science. I say contrary to common opinion because many people now regard science and religion as natural enemies. But this idea is of recent origin. It dates back to the 18th century, and back then was a minority point of view put forward by a handful of political thinkers, most of whom did not practice science. It did not really begin to settle into popular thought until the late 19th century, when a couple books were published which sought to portray religion as an obstacle to science-driven human progress. Unfortunately, these books were widely influential, and the conflict they describe is historically inaccurate and largely trumped up. This is not to say there is no tension between science and religion. There is, but historically speaking, when the tension was felt, it was generally deemed creative and constructive. Each endeavor contributed to the other. Indeed, for ancient scientists, the study of nature almost invariably presupposed a creator God whose beauty and excellence is revealed in the orderly design of nature. The Pythagoreans, for example, upon discovering that musical intervals express mathematical ratios, posited that God is a mathematician. And this view lived on for centuries, influencing Copernicus, Kepler, Galileo, Newton, and as late as the 20th century, Nobel laureate Eugene Wigner, who proposed that, quote, "The miracle of mathematics is a wonderful gift that we neither understand nor deserve," end of quote. Plato championed this outlook also, insisting that music and astronomy are sister sciences because both express mathematical harmonies or periodicities, circuits of intelligence, he called them, which entrain us to think clearly and behave properly. Thus there was no clear line clearly demarcating the study of nature and the quest to improve one's soul. Since each reached back to God, understanding blossomed as the two endeavors merged. To follow Thomas Aquinas, a late medieval theologian who sought to harmonize Christian thought with Aristotelian science, divine revelation does not cancel science, but completes it. Revelation allows us to see the natural world in all its scientific splendor. Let me try to illustrate this long-standing synergy between science and religion by rehearsing my own experience. In 1985, I was pursuing a military career, as mentioned, a wife and family in tow, and was assigned to Fort Devens, Massachusetts. I began to take night school classes in the history of science at Harvard University, enjoying them immensely. As I got to know some of the major figures of Western science, I was surprised again and again by their deep religiosity. I had grown up thinking that most scientists were atheists. This is the unexamined cliché that now prevails in popular culture. But it did not hold up as I studied Copernicus, Kepler, Newton, Leibniz, Faraday, Maxwell, and Einstein, all of whom were deeply religious. Even those that we may now regard as anti-clerical or borderline atheists either developed arguments which presupposed God's existence, like Galileo and Descartes, or they sought to relocate God, or the grandeur of God in a non-traditional setting, like Darwin. If God moves in mysterious ways, thoughts of God were moving in the minds of all these men as they developed their scientific theories. None of them were inclined to dismiss God out of hand. Indeed, they often felt they were rethinking the thoughts of God, or using God's thoughts as a benchmark from which to gauge the correctness of their own ideas. As Einstein remarked to a colleague, "When I am judging a theory, I ask myself whether, if I were God, would I have arranged the world in such a fashion?" Better known is Einstein's rejection of the Copenhagen interpretation of quantum mechanics. Quote, It is hard to sneak a look at God's cards, but that he would choose to play dice with the world is something I cannot believe for a single moment." End of quote. Never mind that most physicists now believe that Einstein was wrong in his opposition to quantum indeterminacy. And never mind that Einstein's God was very different from the God you and I believe in. The salient point is that he felt compelled to align his theories to a divine standard, though he allowed that he might err in his apprehension of that standard. It is hard to sneak a look at God's cards. 3 centuries before Einstein, Newton had similarly tried to sneak a look at God's cards and died believing that he really had pulled it off. So did virtually everyone else. His contemporary, Alexander Pope, thus wrote, "Nature and nature's laws lay hid in night. God said, 'Let Newton be,' and all was light." Newton's science is particularly instructive as to how scientific theory is shaped by religious belief, and then how once the theory becomes established, its religious dimension is forgotten. Think of rocket boosters that are jettisoned once a space shuttle achieves altitude. The boosters provide most of the liftoff thrust, but when the shuttle is in orbit, it is able to travel on its own without boosters. Similarly, Newtonian science got off the ground only as Newton engaged questions of religious import. But once his theory achieved altitude, that is, became consensus thinking in the West, those questions were discarded, and Newtonian science was presented as a fully self-contained intellectual system, one that has nothing to do with God. As Peter Gay put it in his History of the European Enlightenment, thinkers after Newton managed to pass on Newton's physics without Newton's God. Again, it is not so important what exactly Newton believed about God. The important point is that his belief in God motivated his science. Newton was a deeply religious man, one possessed of an overbearing sense of divine presence, according to John Brooke. For him, science was a religious pursuit. That is why aspects of God show up in his science. This is not obvious at first blush, but scholars agree that Newton's scientific concepts of absolute space and absolute time issue up from his theological deliberations. Far from dismissing or excluding God, he wanted his science to incorporate God's active involvement in the cosmos. He consequently determined that God constitutes space and time through his eternity and omnipresence. In some fashion, our experience of space and time, Newton believed, puts us in contact with God. And Newton asserted that space and time, correctly understood, allow us to see things as God sees them, albeit from a limited perspective befitting our mortality. Put differently, Newton felt his physics optimizes what potential we possess for understanding nature precisely, because it lines up with the way God sees the world. Consider what Newton was up against as he sought to formulate a comprehensive explanation of physical reality. With Copernicus, the universe had lost its fixed center, the stationary point of reference from which one could, in an absolutely equivocal way, gauge the motion of bodies in the universe, whereas geocentric models of the universe assumed a fixed Earth and therefore a motionless center. Copernicus's model quickly lost its sun-centeredness to become a universe without a fixed point of reference, and therefore no means of distinguishing absolute motion from relative motion. For Newton, this was unacceptable, and he sought to rectify the situation by characterizing space as an aspect of God, who was an unchanging being. Space thus became for Newton the stationary backdrop against which objects in the universe move. To the extent that objects move relative to this backdrop, they move absolutely. Similarly, to the extent that physical processes unfold temporally relative to God's experience of time, what Newton called absolute time, they unfold absolutely. No need to depend upon our very fallible subjective sense of time, as our scientific instruments, our yardsticks and mechanical clocks improve. They allow us to transcend the subjective realm and arrive at increasingly accurate approximations of God's experience. For 2 centuries, Newton's concepts of absolute space and absolute time went unchallenged. Most scientists liked them because they were, at least in principle, cosmic fixtures against which the motion of physical bodies could be measured. Never mind that no one could witness them empirically. There was a problem, however, and in the early 20th century, a young patent examiner doing physics in his spare time seized upon it to offer a very different vision of reality. Einstein's vision, like Newton's, issued up from metaphysical or aesthetic considerations, that is, considerations of how God, as an all-wise being, would have structured the universe. The problem went back to Newton's postulate that inertial motion is experimentally indistinguishable from rest. Put another way, the laws of physics are the same, yield the same results in all inertial reference frames. The snag for Einstein was that many physicists of his day felt that light waves moving through the universal ether could be used as yardsticks for the detection of absolute inertial motion. Imagine a spaceship moving inertially through space. Passengers on board feel no acceleration and so do not know, in any absolute way, whether they are at rest or in motion. But now suppose the spaceship is overtaken by a light beam. The passengers, upon measuring the speed of the beam, get a value, say, of 9/10 the speed of light. What do they know immediately? That they are moving inertially at 1/10 the speed of light. And in discovering this speed value, they've done something Newton said is impossible. Recall his postulate. The laws of physics do not distinguish between inertial motion and rest. How then could those same laws allow for the determination of a speed value denoting absolute inertial motion? Einstein said he found this scenario unbearable. It violated his sense of cosmic harmony, for it suggested a deep asymmetry in nature. Mechanical experiments, those involving physical objects, cannot detect absolute inertial motion, but optical experiments, those involving light, can. He eventually decided the asymmetry lay not in nature but in physics, and to repair the asymmetry, he took the bold step of recharacterizing the motion of light. It no longer moved at a constant rate relative to the universal ether, but at a constant measured velocity. Any inertial observer measuring the speed of light, regardless of the observer's motion relative to the light beam, will come away with the same speed value, the speed of light. At the time, there was no experimental proof for this, and the proposal itself was, and still is, deeply counterintuitive. After all, what else in the world returns the same speed value even as observers vary their speed relative to it? But Einstein put forward this striking claim because it was the only way he felt he could square things with God. Given the various experimental and theoretical constraints, there was no other way, in his judgment, that God would have arranged the world. Today it is easy and in fact customary to explain Einstein's theory of special relativity without mentioning the metaphysical quandaries and predilections from which the theory emerged. Thus we are given Einstein's science without Einstein's God, just as 3 centuries earlier the world was given Newton's physics without Newton's God. With the theory established, the boosters, that is, the philosophical and theological passions that thrust it into orbit, could be jettisoned. To some degree, this is not a bad thing. Einstein's God was very different from Newton's, and science cannot decide between the two. It can, however, experimentally decide between the two theories when each offers a different physical prediction. Thus, science cannot test theological or religious hypotheses that have no empirical content, but this inability need not imply that science does not bubble up from passions and predilections which it cannot scientifically justify. A case in point is Paul Dirac's well-known declaration that quote, it is more important to have beauty in one's equations than to have them fit experiment, end of quote. To be sure, this axiom worked for Dirac, but could the scientific community ever reach consensus on what exactly constitutes mathematical beauty? And even if some rough consensus were achieved, is it really more important that one's equations be beautiful than that they fit experiment? Or is this just an idiosyncratic point of view befitting Dirac's famously idiosyncratic personality? Science cannot say for sure, but what Dirac's claim demonstrates is that no scientist, even one as adverse to philosophical speculation as Dirac, is free of extra scientific tendencies. These tendencies may be variously regarded as aesthetic, religious, metaphysical, and so on. But whatever we call them, they are the human matrix from which scientific theories ultimately emerge. I could offer many examples, but will, in the interest of time, limit myself to just 2, both of which illustrate the role of religious belief in the genesis of scientific theory. First, Johannes Kepler, whose 3 laws of planetary motion constitute the basis of modern astronomy. It is easy to present these laws as self-contained principles, as if they are the products of dispassionate observation and calculation. Granted, without Tycho Brahe's observations and his own heavy calculational labor, Kepler would not have discovered the laws. But that discovery was anything but dispassionate. Kepler's question, do we ask what profit the little bird hopes for in singing, reflected his belief that humans were also made to sing the praises of God's creation, and that God has structured the world as an inexhaustible treasure trove to keep the human spirit growing, as it forever delights in new discoveries. In 1595, when he hit upon what he thought was the geocentric layout of the Copernican solar system, he felt that he had lifted the veil which hides the majesty of God, and had been given a glimpse into its profound glory. Now, he says, I no longer bemoaned the lost time. I no longer became weary at work. I shunned no calculation, no matter how difficult. I vowed to God, the omnipotent and all-merciful, that at the first opportunity I would make public in print this wonderful example of his wisdom, and sing unanimous praise and glory to the all-wise Creator. End of quote. As we look back on this episode, we may reflect that the discovery was ill-conceived because Kepler was still locked into the age-old belief that planets move in circles. All the same, his worshipful enthusiasm for God's creation motivated years of subsequent effort, culminating with his self-declared war on Mars and the realization that the ellipse, not the circle, describes planetary orbits. Once this realization was fully developed, Kepler had his 3 laws of planetary motion, and the vision those laws inspired transported him heavenward. He wrote, I feel carried away and possessed by an unutterable rapture over the divine spectacle of heavenly harmony. Michael Faraday is my last example. Arguably the greatest of the British experimentalists, Faraday had poor math skills, but this seems to have hardly mattered, for whereas Dirac followed his sense of mathematical beauty, and Einstein his sense of how God would have arranged the world, Faraday put his faith in Christian scripture, and Romans chapter 1, verse 20 was his scientific pole star. For the invisible things of God from the creation of the world are clearly seen, being understood by the things that are made, even his eternal power and Godhead. This passage, along with many others, persuaded Faraday that the objects of our everyday experience, visible things like stars, rocks, tables, and chairs, originate from an unseen realm of divine action. He accordingly rejected the materialistic thesis of 19th century physics. On this view, everything begins with material objects, which are said to be self-existing, distributed throughout empty space, and originative of forces acting between bodies, that is, acting across empty space, which separates bodies. This description of reality may sound simple and straightforward, but long before Faraday's, thinkers had asserted that it is in some ways incoherent. For one thing, how are forces transmitted across empty space? This question was particularly vexing since force, as science had conceived it, was transferred only as one material body directly impacted another. But if empty space separated two bodies, how did the transfer occur? Skeptical of materialism and of scientific models that privileged material atoms as the bedrock of physical reality, Faraday was prepared to forge a new vision of nature. This did not happen overnight, of course. It occurred over about 3 decades, as Faraday worked experimentally to understand electricity, magnetism, gravity, and light, and faithful to his belief that the invisible things of God are intuited through the things we see, he let his laboratory findings, results he could see, disabuse him of scientific understandings that others could only imagine. For example, what is the nature of magnetic force? Is it a straight-line force that diminishes with difference? Of course, it can be mathematically modeled as such, but Faraday saw it as a curved force when he spread iron filings on a piece of paper with a magnet underneath. For him, the sense of resting curved force lines were primitive, and from the very first he guessed that they denoted states of tension in and around the magnet. From a modern perspective, the lines happily compelled Faraday to think more broadly than his contemporaries, who were content to think of material bodies as self-contained, self-existing bodies acting rectilinearly across empty space. He, by contrast, entertained the possibility that atoms, the so-called building blocks of material reality, come about as lines of force crisscross to produce points of tension. Enough buildup of tension, when stabilized, produces the larger material objects of everyday experience. Seen this way, the visible things of creation are brought into existence by invisible forces, forces that Faraday, following Apostle Paul, identified as God's eternal power. Among the first to appreciate Faraday's new vision of reality was James Clerk Maxwell, a Scottish physicist who translated the vision into mathematical formulae. In his assessment of Faraday's accomplishment, Maxwell wrote, quote, "Faraday in his mind's eye saw lines of force traversing all space, where mathematicians saw centers of force attracting at a distance. Faraday's methods resembled those in which we begin with the whole and arrive at the parts by analysis, while the ordinary mathematical methods were founded on the principle of beginning with the parts and building up the whole by synthesis, end of quote. Faraday's inclination to begin with the whole was sparked by the patterned relationships traced out by curved lines of force. Because the lines were not cleanly geometric and had more of a physical than a mathematical feel to them, they prompted Faraday to see space as an active physical participant in the configuration of reality. By their intersecting multiplicity and shifting density, the lines connoted relationality and far-flung interconnection, and not just as an afterthought to self-contained material bodies, but as primal truth. With Maxwell's help, Faraday's outlook morphed into the first modern field theory. As the term indicates, field theories embrace relatively large swaths of space and assume that these swaths possess properties that play into particle behavior and sometimes localize as particles. A line between field and particle, or space and matter, in other words, cannot be clearly drawn. Moreover, given the energetic nature of the field, what Faraday might have called its force-filled nature, and the difficulty of distinguishing between field and particle, particles register as blips of energy rather than hard, massy, long-lived material entities. Faraday was the first to step into this strange thought world, one that still resists easy comprehension. For him, the web of force lines was the matrix of creation, and an affirmation of his religious belief that the invisible things of God are clearly seen by the things that are made. Although field theory is now a major aspect of modern physics, few recall how religious belief shaped it in its infancy. Again, the boosters that helped launch the theory have been jettisoned, and we have been given Faraday's science without Faraday's God. I have no problem with this so long as we occasionally recall that there is more to the story of science than science proper, and that a big part of that story is religious belief. It is proverbial that science deals with things that have empirical properties, things that can be seen, heard, and touched, while religion concerns itself with things beyond the reach of empirical apprehension. In my view, this is an idealization, because science is always relocating the boundary between the seen and the unseen. The universal ether of the 19th century, which many regarded as the physical realization of Newton's absolute space, could not be seen, that is, experimentally detected, in any way, even though the wave theory of light demanded its existence. And when Einstein dismissed the ether, he turned light, which up to that time had struck most people as among the most obvious of all phenomena, into something quite different and mind-stretching. Its speed became a space-time metric, rather than, as was previously thought, merely the rate at which light moves through space and time. In brief, Einstein deepened our understanding of light in ways that suggest there is much more to light than what we see. Quantum physics, of course, prompts the same suggestion, albeit in a different manner. Finally, Faraday, in pioneering field theory, performed a demolition job on the classical atom, the hard, massy, self-contained atom, which earlier generations of scientists could not see but had little trouble visualizing. Is there a clear boundary between what we see and don't see? And if not, is there a clear boundary between science and religion? When I was 9 years old, I learned that an empty glass put upside down in water is not empty. The unseen air has a presence just as real as the very wet, very visible water. To its credit, science keeps discovering new realms of emptiness, which upon further inspection turn out to have some kind of presence or reality. Let me give a couple of examples. The ellipse was discovered by Apollonius about 250 BC. That is, it was mathematically realized, although no one has suspected that it had any physical relevance. Nearly 2,000 years would pass before Kepler found the ellipse in the physical heavens. About the same time, while studying projectile bodies, Galileo found the parabola, another mathematical curve that for centuries had been waiting patiently for our wits to grow sharper so that we could find it in the natural world. Similarly, non-Euclidean geometries were developed in the 19th century, but people felt that these were nothing but toy worlds, that is, interesting mathematical diversions having no physical import. Then Einstein seized upon one of those geometries to develop his general theory of relativity, and now we know the physical reality is non-Euclidean. Granted, many ideas do not pan out, but some do, and some of these, when first presented, seem empty of physical significance. Here I am reminded of Doctrine and Covenants, section 88, verse 37, quote, "And there are many kingdoms, for there is no space in which there is no kingdom, and there is no kingdom in which there is no space, either a greater or lesser kingdom," end of quote. In my opinion, this passage marks the trajectory of science by suggesting that no matter how deeply we go, there will always be deeper realms to explore. Why? Because kingdoms fill up space. There is no kingdom in which there is no space in which there is no kingdom, and vice versa. And there is no kingdom in which there is no space. Kingdoms and space mutually inform each other, each filling or penetrating the other as deeply as the mind can reach. On this view, so-called empty space is merely an invitation to dive deeper. It comes off as something that keeps opening up, keeps being spacious, accommodating, even graciously self-vacating, so as to make room for yet another kingdom. Trying to find the bottommost kingdom or reality will always entail finding space for yet another kingdom ad infinitum. Hence there are kingdoms or worlds without number. Think of Kepler's belief that God has structured the world as an inexhaustible treasure trove to keep the human spirit growing as it forever delights in new discoveries. Or think of the everyday activity of walking toward the horizon in search of new experiences, whereupon the old horizon continually gives way to new horizons. You nimbly observe that some desert Bedouins reflexively assume that life goes on forever because, travel as they may, they never reach the horizon. Upon giving way to our attempts to understand it, the world offers us new horizons and thereby takes on new configurations. This, I believe, is the arc along which both science and religion move. As a young boy, Einstein was deeply impressed by the way the needle of a magnetic compass invariably springs northward. This taught him, he tells us, that there are unseen forces in the world, that there must be, quote, something behind things, something deeply hidden, end of quote. Most people, scientists included, would agree. And as long as this is the case, it will be difficult to keep religion, which also posits the presence of unseen powers in the world, out of the practice of science. Thank you. Well, I'll
Give me the microphone.
okay, I'll give you the mic.
Thank you very much. We invite your questions. I have a few. If anybody would like to raise their hand, I'll call on you first. Otherwise, I'll grab it. Go ahead.
I believe you wrote a review of a book, and I think it was by a gentleman you had mentioned earlier, an atheist.
Oh, Richard Dawkins.
Richard Dawkins. Yeah.
Correct.
In which you, after reading his book, commented, I believe, that you didn't believe in the God he described either.
That's right.
And my question is, it seems that most arguments are, as you stated, against false
I don't know if I thought too much about that. I think it's, like you say, it's human nature, and I think you have people, I mean, if I can just talk about Richard Dawkins, I mean, he's a very high-profile atheist. He's also a biologist of some reputation, but he's, for many years, for decades, he's been writing against the Christian God. And I don't know, I would guess with Dawkins, he doesn't take the time to really find out what we believe. Well, maybe that's a bit of an overstatement, but I think it's just his temperament, and I think he knows what he's doing. I think there's something, I think he realizes at some level, as I tried to point out in this review, his argument becomes incoherent, even by his own standards, I mean, by the standards of rationality. What he's opposed to, as he talks about in the book, is not God per se. It's just a personal God, right? I guess it burns him when he thinks of people praying to God, supplicating God, and he just feels like that's contrary to science. But the whole, as I tried to point out in the book, this is worldview warfare. It's not really science versus religion, I think. He has a worldview, and so he uses his understanding of science, and he mischaracterizes religion, but he uses his understanding of science as a kind of hammer with which to beat up on religious believers. In the process, as you say, and as I said, mischaracterizing our beliefs. But I think I also said in that most people don't read him at a very deep level. And if you don't read him at a very deep level, everything comes off as persuasive. But if you take the time to kind of interrogate what he's saying, think about it, then you see that it kind of bottoms out into a kind of leap of faith itself. He's got his own religion, right? As I say there, he's a religious firebrand in scientific guise. He's dressed up like a scientist. He presents himself as a scientist, but really what he's doing is he's fighting religious fire with his own religious fire, with his own passion. That's my take. Please.
Previous question was asked, what I thought was perhaps the reason that people are always questioning about God is actually that need to find new horizons. And it's that need to ask yourself, is the other guy wrong? Is there something that I can find out that other people haven't?
Sure. I agree. We can't be dogmatic. I mean, I think the thing with, Dawkins and people like him, Daniel Dennett and other people, they're not looking for dialogue. They're just, they're doing diatribe, right? And so, you just have to get used to it. These people will be around.
You have a book that you co-authored that specifically talks about how views on magic and the occult
Yeah.
influence science.
Yeah.
I was wondering if you could make a small comment for us on that.
Well, that book, I co-authored the book. It goes back to my graduate days at Indiana University. One of the historians of science, I was in a history and philosophy of science program, and one of the professors there, he was a well-known, highly regarded historian of medieval science, had taught that course for a long time, and he was getting ready to retire, and he turned it over to me and another graduate student, and you think, well, why are these people, these students who are trying to understand the history of science, studying things like astrology and alchemy and those kinds of things. But, historians of science will tell you that, if you go back a few centuries, you'll find a real tight interconnection between astrology, say, and astronomy. I mean, now we differentiate. They're worlds apart. But if you go back to Ptolemy, 150 AD, a great astronomer, and even Kepler, 1600, I mean, Kepler, just to support himself, he cast horoscopes. So what we discovered through teaching that class was that you go back enough centuries and you're going to find that there's this real interesting and intimate relationship between some of these, we call them occult disciplines now, and the scientific disciplines that we teach today. And of course, we've thrown those occult disciplines in the trash bin, so to speak. But historically, it's all very interesting. And so eventually, my friend, he was a fellow graduate student, when we got started on this, we made a book proposal to Indiana University Press, and they published the book. I think everybody knows that, alchemy, we say, well, we don't believe in alchemy. We don't believe that you can produce the philosopher's stone. Well, Newton didn't know that. It's calculated that he spent more time immersing himself in alchemy than he did in physics, right? And you think, well, that's so lamentable. That's too bad he did this, the great intellect. But what the scholars will tell you is that if he hadn't have been involved in alchemy, he never would have produced the physics that he produced, that revolutionized the world. Those two are a single package, and I don't have time to get into that. But that, for me, makes the history of science very interesting, and that's one of the reasons we wrote the book.
So you just answered one of them about Kepler, because he's sort of taught as being kind of a stumble bum through science, and one of the ways he stumbled was his dabbling with horoscopes and so on.
Yeah.
Was that, you said that was to support himself more, or was that reflective of his beliefs in God or anything?
I think, I'm not a Kepler scholar, but I think by the time you get to Kepler, the two disciplines, astrology and astronomy, had begun to diverge, but they certainly weren't as far apart as they are today. But Kepler's, again, very interesting because, well, as you can say, he's very religious, but when I teach my history of science class, one of the things we always listen to is his composition of the music of the spheres, right? This age-old belief that goes back to about 500 BC. I mentioned in the paper the Pythagoreans had developed this idea that God is a mathematician, because when they plucked a guitar string, so to speak, what we might call a monochord more formally, they discovered the octave, they discovered the different musical intervals, and they says, all of reality is structured according to mathematical ratios. Well, like I say, this idea of the harmony of the world, the harmony of the spheres, tumbled down through the centuries and ended up in Kepler's lap. And the last book he published was The Harmony of the World, which I don't think anybody in astronomy studies anymore. But it was supposed to help students of astronomy appreciate what was going on out there in the heavens. Of course, that's a wavelength you would never think along as an astronomer. But it makes Kepler a very interesting person. And here again, I think a lot of people, most Kepler scholars would say that if he hadn't have done that, if he hadn't have gathered up the gravel, so to speak, he wouldn't have gotten those gold nuggets that we prize so highly today.
I have one other question. You talked about Einstein and his religious foundations.
Yeah.
He always said he believed in the God of Spinoza.
Yeah.
What does that mean?
Well, yeah, Spinoza was a 17th century thinker. What that means basically is that Einstein's God is not available for religious purposes. That's why I say in the paper, Einstein's God is very different from our God. Einstein didn't. Basically, he's a pantheist. Einstein identified God with the laws of nature, and it was a completely impersonal God. He used to say that it's not a God you can pray to. I mean, because how can you pray to the laws of nature?
So when he says, I want to know God's thoughts,
Yeah, I know.
who's thinking?
Well, I think it's just that he believes, it's not a God that is, well, this God is completely oblivious to us and maybe even oblivious to all creation. But I think what's important is that Einstein felt like the universe was informed by some sort of transhuman, what he would call divine intelligence, or what we would call divine. He's certainly not an atheist. He doesn't feel like the universe came about through just some higgledy-piggledy process. That there is some sort of divine standard there, and through the exercise of science, we can peek into the mind of God and see that standard. Please.
How has the emergence of quantum physics affected the interplay between science and religion, and how do you see it affecting it in the future?
Well, there are probably a lot of people here, if anybody's ever taken a quantum physics class, or there are a lot of books out there, and of course I think quantum physics has opened up the debate. That's what I would say. Not that it's decided anything, because you can go to either end of the spectrum, and there are people that will say that so what if there's randomness or indeterminacy in the world at some deep level, right? And so what? That doesn't necessarily mean that that's where God slips in to natural process. But then at the other end of the spectrum, you have a lot of people that will make that very argument, and then will say, and I guess the first book I ever read on quantum physics, it's just a popular book, but it's one that I'm sure is still in print. It's sold millions. It's the Tao of Physics. Maybe some of you have read that, but they're the argument, and it's a physicist who develops the argument. He says, well, we got quantum physics now, and then we have these age-old Eastern religions. So there's Taoism, Buddhism, and those kinds of religions. And quantum physicists in the 20th century are rediscovering these old insights into reality. And like I say, this book has just been a monumental bestseller, never goes out of print. And a lot of people look at that and just say, this is wonderful. This humanizes science, right? But it doesn't ultimately decide anything, in my opinion.
One more comment. When you think about quantum entanglement
Yeah.
and things like that, that's almost spooky.
Yeah, that's what Einstein called it.
Kind of mystical.
Yeah, quantum entanglement, at least for me, is the most liberating idea in science. And that's not to say I can make sense of it, but I just think it just opens a big window, and that's not to say that whatever I would say about it, and I have written about it, would persuade you or persuade a lot of people, but at least for me, I find it deeply interesting and deeply satisfying. Yeah.
Well, let's thank Dr. Grandy again.
Thank you.